Okay, and we are live. Hi guys, welcome again to another VJAC session. This time we're going to talk a little bit about session hijacking in Java EE. The complete topic is actually the hacker guide to session hijacking in Java EE. One thing that's probably a little bit different is usually Simon that's doing these sessions, but today he was not able to do it, so he asked me to do it for him. So thank you, Simon, for giving me the chance to help you out on this one. And today we have Patrycja with us. Hi, Patrycja, how are you?
I'm fine. Hello, everyone. And I'm really excited to be here.
Awesome. Yeah, thank you so much for taking the time to be with us here on our VJAC session. So for all our viewers, please join us on the RSC channel, VirtualJug. Just go to virtualjug.com. Join the RSC channel there, and we'll be happy to relay back to Patrycja any questions that you might have during her presentation or in the end, depending on how Patrycja prefers to do that. It's going to be a little bit of interactive session. Patrycja is going to send us a few links so you can try them out. Do you want us to brief us a little bit about that, Patrycja?
I think I will do that during the session.
Okay, awesome. So without further delay, please go on with your session. Please introduce a little bit yourself to your audience, and we're happy to have you here.
Okay, so once again, hi everyone. My name is Patrycja Wegrzynowicz, and today I'm going to tell you about session hijacking, including secure authentication and session management in Java EE. Briefly about myself, I've been doing professional software development for nearly 20 years. I've always been close to code, and I still am, and I have to say I love it. I'm the founder and CTO of Yonita. Yonita is a startup where we aim at bridging the gap between the industry and the academia. In addition to trainings and code reviews, we work on automated tools for detection and refactoring of defects in software, including, among others, security vulnerabilities. So basically, security vulnerabilities are my daily job, as well as other ways of shooting yourself in the foot with Java programming. Also, please remember my Twitter handle, which is YonLabs, because we will use it heavily during the session. The links will be posted to my Twitter account and the VirtualJug IRC channel as well. What am I going to talk about today? First, a brief introduction to security problems, HTTP, and session concept. The key part of today's talk includes 4 demos that illustrate how to hijack the session, how to use XSS to steal the user's session, or how to exploit CSRF to use the session without the user's permission or even without his knowledge. So for last 2 decades, web technologies have experienced a significant growth. The number, the size, and the complexity of web applications have increased substantially. Unsurprisingly, many new techniques to attack IT applications have been developed as well. The years 2014 and 2015 showed that pretty well. I'm sure that you remember Heartbleed in OpenSSL, also famous shell shock attack in Bash, to name a few. Also, anyone heard about Logjam? Basically, it's, again, the attack on TLS protocol, particularly Diffie-Hellman key exchange, which allows a man-in-the-middle attack and downgrading the encryption, and in the result, full access to transfer data. Additionally, basically, every month brings new data breaches. During recent years, hash passwords and credit cards have leaked from such prominent companies like LinkedIn, Amazon, or eBay, to name only big players. So there is no doubt security is important in today's world. But let's get back to the web. HTTP is the foundation of data communication for the World Wide Web. It's a stateless application protocol based on a request-response communication schema. And what does it mean it's stateless? It means that each request is processed independently. And as we think of web applications, there is an obvious need for statefulness. We must keep track of user authentication and keep track of his interaction with the application to display, for example, personalized data. Let us think about like users' permissions to perform a given function. We need to keep track of, for example, his shopping basket, and so on and so on. So how can we achieve that? That's the place where a web session comes in handy. A web session identifies interaction with one user. The implementation is simple. We need to associate a unique identifier with every request from the same user. So in Java, this identifier is named by default JSessionID and is implemented as a cookie or URL parameter. So everything works great. So what's the problem? The problem's here. Broken authentication and session management is number 2 on the list of the top 10 security risks according to OWASP. OWASP stands for Open Web Application Security Project. It's a non-for-profit organization which aims at increasing security awareness among developers. And every 2 or 3 years, OWASP publishes the list of top 10 security vulnerabilities in web applications. It turns out that authentication and session management cause a lot of troubles to software developers. The problem is that we, as developers, rely on the platform. We rely on session ID as a single mean to identify the user, and we don't protect the session ID carefully enough. So all this means that our sessions are very easy targets for hijacking. And there are 3 primary types of session attacks. The first one is to steal the user session ID. The theft can be done by various means. A session ID can be exposed in URL. We can sniff a session ID monitoring network traffic, or we can see it in server logs, or we can steal it via XSS. The second type of the session attacks is to fix a session ID and to trick a user to log in with our fixed session ID. And the third one is to guess the session ID in cases where the algorithm which is used to generate a session ID is too weak. The last one is the least likely in the Java world, but still it's useful to know about that. So now it's time for the first demo. I will log into my sample application. I will post a link with my session ID on Twitter, and you will hijack my session ID.
Awesome. I love demos. Looking forward to it.
Okay. So that's a very simple application. I'm logging in. And you will see my session ID in URL. I will post this link to the Twitter, and then you can click the secrets button and find out my secrets. Okay, so demo 1 and my session ID. For those of you who are a little bit impatient, I can click the secrets button and we can see who has already done that. We see so far 4 different users from 4 different IPs using Safari, Firefox, and again, Safari on Windows. Oh, no. Or Windows NT. Yep. So.
And they keep coming. 7, 9,
yes,
10.
Absolutely.
Awesome.
So we'll see a lot of different users who managed to access my session and to reveal my favorite pet, which is a mandatory kitten picture. And yes,
I'll just open up multiple browsers.
Yes, multiple browsers, multiple IPs, and different operating systems. So all of you managed to hijack my session. Let's get back to the presentation. What was the main problem? The problem was that the session ID was exposed in URL. Think of all those public places we serve the web in, like in coffee shops, during lectures, at conferences, and imagine how easy it's to take a photo of our screen and so on. And you've just seen that it's even easier to use the captured session ID later on. The default behavior of Java web application is that it allows cookies as well as URL rewriting. So cookies are the first choice, but an application falls back on a URL rewriting in case of cookies disabled in a browser.
So for our audience, for them to understand, what will be the worst thing that can happen if someone hijacks your session? What's the worst story that you heard about by someone hacking a session and wrecking?
Think about bank applications or something like that. By hijacking bank applications and session hijacking of bank applications, you can get access to your private account. So that's the main issue when a hacker gets access to our private data, and it can discover our confidential data. He can use the application in a malicious manner and so on.
So if a bank doesn't develop their system properly, an hacker can just easily grab the session ID and actually transfer money from my account to his own account or whatever account he wants, right?
Yes, exactly the case. So luckily, most bank applications are secure enough, but still it happens that from time to time, more sophisticated types of attacks on bank accounts still happen.
Yeah, well, guys, remember to check the address next time you visit your home banking account.
Absolutely. As a side note, I gave security training to some bank developers, and unfortunately, they learned during the training that the application is not secure enough. So it was not a simple problem with session exposed in URL, but more complex about session management and some corner cases, which we learn more later during the session.
Well, I'm not sure if you can share that information with us, but I mean, if you're able to do it, we would love to hear those stories.
maybe not all the details.
Sure, of course. We understand whatever you can share. It will be useful information for everyone.
Yeah, sure.
Yeah, but please proceed. Sorry about that.
No problem. So basically, there are two options to disable URL rewriting. We can disable URL rewriting in an application server, and this is an application server specific configuration, or we can use a tracking mode, the configuration parameter in web.xml. By setting tracking mode in session config in web.xml to cookie, we disable URL rewriting, and this parameter is available since Java EE 6 and Servlet 3.0 specification. Even if we disable URL rewriting, hackers can still eavesdrop users' session IDs. However, now they need to put more effort into it. For example, they can use network monitoring and packet sniffing tools. Once they find out session ID, they can use it as a cookie. They can use a plugin or add-on for a browser that enables cookie management, like Cookie Manager for Firefox. They can use intercepting proxy that allows to modify HTTP requests, like OWASP, ZAP, Z attack proxy. Finally, they can write their own code to connect to the app in question. And now it's time for another demo. You've already hijacked my session. Now it's time for me to hijack one of yours. I will use two tools, TCP dump for network monitoring and Cookie Manager for Firefox to intercept HTTP request and set up the cookie. The application is almost the same as the last one. I've only changed the tracking mode to cookie and the authentication realm to the custom realm that allows any non-empty username to log in. Okay, so I will post a link to the second demo on Twitter. Demo with session ID stored in a cookie. Also, I will log in. I'm already logged to my server, and I will run a TCP dump. And now I'm waiting for you to log in to this application. You can use whatever username you want and whatever password you want. And once you log in, I will see your session ID in my log. Okay, there are many requests. There are many requests going in. I will try to
find me.
That's difficult. I will find any session which is ready to use. I'm looking for a response to get the correct cookie. Okay, probably this one will work. We'll see. Okay, so now I'm using Cookie Manager, and okay, this one, and take a look that I'm simply changing the value of my cookie to the one I've just seen in the log. And we'll see which user I managed to hijack the session of. Oh, it's pretty difficult to pronounce. Gebab.
Gebab. Who's Gebab?
Yeah. Anyone here?
Let's see. Oh. Gebab, go to IRC and you'll get the prize.
Yes, absolutely.
Okay. We'll give you the next book from the Book Reading Club.
Okay, I will try. I will try another session. Oops. Sorry. My phone was not muted. Okay. I will try another session and make use of, for example, this session ID to manage to hijack another session. I'm looking for a response. Okay. Yes, this one. Okay. Once again, that's the simplest one, the simplest method to changing your session cookie. If you want to modify other HTTP parameters as well, you can use any application proxy, intercepting proxy, which allows for modification of the full HTTP requests. At the moment, we need only session cookies, so Cookie Manager is a very handy tool. Okay, saving. And oh, I think I haven't saved that. Yes, now I managed to do that. Oh, still the same user.
Still Gebab. He's trying to hack you.
Yeah, maybe. Maybe some other user. Okay.
I'll try to log in again with another browser to give you
that would be great.
More sessions for you.
Yes, because okay, we have a very, very long clock. Once again.
Here you go.
Okay. I think yeah, now we have Jack.
Jack the pirate.
So give up or check any one of them is on IRC channel. Roberto?
Jack, are you on IRC? Well, he's probably only going to hear this after 30 seconds. So.
Yeah, that's true. Okay.
I'll let you know if he gives me an answer.
That would be nice. So let's get back to our slides. And it's time to learn how to avoid session exposure during transport. Well,
we actually have Gebab on IRC.
Oh, that's great. Congratulations. So basically, how to avoid session exposure during transport. That's elementary. And I guess most of you have already guessed that. That's encrypt. Encrypt our transport channel and use HTTPS instead of plain HTTP. And use it properly. Remember about Heartbleed in OpenSSL and logjam in Diffie-Hellman. And how to configure that? First, in web.xml, we set up a security constraint to use a transport guarantee set to confidential. And then also in web.xml, we configure the secure flag for cookies. It prohibits browsers from sending cookies over unencrypted channels. That's very important because we guarantee that cookies will be sent only over HTTPS. This configuration parameter, yes, Roberto?
Yeah, so just a quick question is, I'm getting a little bit confused on something, is that we have all these problems, all these session IDs and people hijacking sessions. I mean, that's something that I will expect the framework that I'm using to actually provide that for me right on defaults, right? So why do we have to set it up with some different configuration? Is there any reason why we don't want that to have this level of security?
You know, for example, for performance reasons, for less secure applications, we don't need to use HTTPS, right? HTTPS is obviously a performance, adds additional performance overhead. That's one reason I could think of when it comes to HTTP, plain HTTP usage. Plus, think about the development mode. Unfortunately, we are pretty lazy beasts as developers, and we want to set up our environment pretty quickly. In terms of HTTPS, to set up it properly, we need to use a correct certificate, because otherwise the browser will warn us about incorrect certificate being used.
Yes.
I don't think those arguments are very strong, but still probably those are some arguments one could use in favor of HTTP.
Sure. I'm thinking about the junior developer that doesn't really know about these problems yet, right? Because he's still learning. And then he might develop like an unsafe application because the framework or the tools didn't shield them against it, and he doesn't even know about these configurations. And then he's probably only going to find out when his application's hacked or something.
Yes, and that's exactly the case. I'm not sure why Java EE and Java spec has been developed in such a way which allows for such default unsecure behavior. This is the fact. The reasons behind this fact, you can think about some back compatibility, etc., etc. So it's getting better. Developers are well trained in security, or better trained in security than they used to be. So all in all, I think that the average level of the security of the applications getting better. But still we have a long way to go to make very good applications in Java EE. And obviously, developers must be aware about all those problems and all those parameters to configure. So in case of secure flag, this one is very important, because think about, for example, a serving of images. Usually images are served from a different HTTP context, usually over plain HTTP. And in case of the cookie for the same domain name, it might happen that if you don't use a secure flag, the cookie will be sent over unsecure, unencrypted channel. So before Java EE6, we had to do to put a lot of work to make it working. Like, for example, we had to implement additional interceptor. From Java EE6, we only need to configure a secure parameter And that's all.
Awesome.
So far, we've made sure that our session ID won't leak during transport, but there are two other places our session ID can be exposed: the client side and the server side. On the client side, the typical attack to steal a session ID involves cross-site scripting, but also beware of malware that is spread via email, exploits browsers, or OS vulnerabilities. Remember that if something can access your browser data, it means it can steal your session as well. So usually we don't care so much about the server side, but remember that many attacks are performed by insiders. Don't store users' session IDs in your logs. Think of secure channels for session replication in your app server clusters, and so on. I think that application server clusters are not used so often anymore, but still during my talks, when I ask the audience about usage of server clusters, still it happens that a few hands are raised. So still server clusters are in use together with session replications. So remember about secure channels.
Yeah, I think that a lot of people still use those, especially for legacy systems.
Yes, exactly the case. So now we managed to secure the transport. It's not that easy to steal a session when HTTPS is used. Well, first we need to check if we don't use OpenSSL with unpatched heartbleed bug. And how can we steal a session if secure transport is used? Any ideas, Roberto?
Sorry?
Any ideas how to steal a session if secure transport is used?
Oh, well, that's why I'm seeing this session, because I don't know that. So I'm hoping that you can enlighten me.
Okay, client is usually a soft spot, so we'll attack client.
Actually, there were a couple of people here that were asking for you to hack the IRC channel.
I think that would require a little bit more work than
Probably.
our quick
But
session.
It will be a nice demo to do the next session.
Okay, I will think about that, and I will prepare for that for sure. Okay, so we'll attack a client. To steal a session via XSS, we need 3 pieces of code working together. The first one is a JavaScript code to steal a cookie. The second one is a servlet that logs down stolen cookies. And the last but not least, there is a vulnerable application that will exploit via injected JavaScript code. Okay, so it's time for our third demo. This time it's session XSS. I will log in to the application. I will write opinion about virtual jack and how awesome it is. And I will include a vulnerable and malicious script into it. The script is very simple. It's just a URL which includes the value of cookie, and it's loaded into source of an image. This is a trick to load URL from a different domain name, because the browser policy is to only allow loading of URLs from the same domain name as the application is.
Mm-hmm.
Okay, so I'm going back to the browser and writing how awesome virtual jack is, and including my malicious script. I'm adding this opinion. And now I will ask our users to log into this application and to view others' opinions.
Yeah. Can you post the link on the Twitter?
Yes, I'm just doing that.
Okay, cool.
Okay, so it's hijack, demo free, with XSS, and we are waiting for the user to log in. And what happens when they log in and they are viewing the other's opinion? When you go to this page, you will see only virtual jack is awesome. But when you take a look at the page source, you will see the script is included. And actually, it's executed. So basically, now I will observe the logs and see which new cookies will be stored in my logs, which stolen cookies are written down in my log. Okay, I see one cookie, animal coming in. Roberto, could you please try to...
Yeah, I'm doing it right now.
You need to log in and to see the others' opinion page. Okay, we see many cookies coming in.
I'm Mr. X, by the way. So.
Okay. So I will try to change the cookie for this page. Okay, I managed to do that. Oh, I see John. Okay, so we managed to hijack John's session. Donald Trump, I see. That's interesting. Okay, let's try another cookie. And we can try another way of changing cookie, just for you to see OWASP intercepting proxy. That's another work by OWASP organization. So they've implemented intercepting proxy, which can be used to intercept HTTPs and as a penetration testing tool for finding vulnerabilities in your web applications. So basically, first I need to configure a proxy in my Firefox. Okay. Manual proxy configuration. My proxy works on my local machine on the port 9090. So that's enough. And now I will configure a breakpoint on Yonita.com URL. So every time a request to this domain name is sent, then the proxy will stop and will allow me to see HTTP requests and to modify it. So now the proxy is configured, and I will try to... Okay, that's the problem. At the moment, there is a problem with secure connection because we are using proxy, so the browser cannot verify the certificate because it's connecting to a proxy only, not to the actual server. I've added the exception to my browser. And now you are seeing intercepted requests. We have a cookie here. I will try to use another cookie. We have a problem here because when you are using OWASP Z proxy, it blocks another Windows, and I didn't copy any other requests, so I need to go through this. I need to copy another request and do the same again. Okay. Once again, I'm refreshing the page, so another request is issued. And I'm trying to modify JSession ID cookie to another one. And just going. Okay. And now I'm a different user, and Tanis. So I managed to hijack Tanis by using application proxy. So that was a simple one. When you are using application proxy, you are allowed to change any of HTTP headers or parameters, so you have more ways to modify and hijack the application. For simple cookie hijacking, it's better to use Cookie Manager or a more simple tool.
It's incredible how easy it is to hijack someone's session using these kind of methods. So in your opinion, probably it's hard to answer this question, but your opinion, how safe or unsafe do you believe the internet is at the moment with this kind of attacks and vulnerabilities on the applications all around?
The vulnerabilities and the problems I'm showing you today are the simplest one. Because usually when you think about more complex attacks on an application, it's just a mixture of different vulnerabilities of applications, sometimes very small vulnerabilities. So basically, I think that most well-known services are usually pretty well secured. But when it comes to our development for smaller companies, it usually is. Those applications usually require much more work to make them secure. Because I remember myself from like 15 years back, my answer to the security officer about the security of my applications I developed that time was, come on, I'm using Java EE. The platform will do that for me. I was not aware of how much more work I need to put in my application to make them secure, even though I used Java EE that time. So basically, we as developers need to learn, because you were very right when you said that people think about security when someone hacks their site. That's the moment they focus on security and on securing the applications.
So you gave an example about Java EE, that you used Java EE and you thought it was secure enough when you developed your first few applications. And we see that that's not the case. Do you believe or do you know any other framework that's around, not exactly Java EE, but any other technology that actually does this work for you? Or every developer, or independently on what technology or language they use, they always have to worry about these kind of issues?
I think that no matter what framework you use, you need to be aware about the problems and the solutions. You need to check how your framework implements security. You can't rely on only on marketing that my framework is the most secure one. You need to check it out on yourself. That's my advice. Don't trust anyone. Check it yourself. Because and you need to keep checking that, because there are many vulnerabilities which are discovered in Java application frameworks, Java application libraries, open source libraries, and you need to check and update to the latest version, which, for example, patch the discovered vulnerabilities. So you need to keep an eye on what's going on in your environment and with libraries you use, with application server you use, just to update on time.
Well, I understand.
Okay, so let's get back to the slides. Okay, so you've already seen how to construct the simplest XSS to steal a cookie. It's important to remember about same origin policy in browsers. That's why we had to use that image source in order to bypass that policy. But that's a very simple trick, and everyone can do that.
Yes, so we actually have one of our RC users, actually was guest 21266, asking about what was the new image source in the malicious script.
Sorry, could you please repeat?
Oh, sorry, we have one user on IRC that was asking about what was the new image source in the malicious script. What was it used for?
Because we want to plan our, because the browsers implement same origin policy. So if JavaScript wants to connect to a URL, the browser checks whether URL comes from the same domain name as the application. So in case of malicious application which stores the cookies, most likely it will come from a different domain name, right? Because the hacker wants to connect to his server, not to the application server, the application in question. So to bypass this browser policy, we cannot connect to this URL directly. The hacker needs to use this trick to load the URL to image source, because images and scripts are allowed to be loaded from a different domain name, because from for the performance reasons, they are often served from the different contexts. So that's the only exception to the same origin policy: images and scripts. Okay, so how can we avoid this kind of attack? First, I want to say that here we focus only on the session side. I will not discuss XSS and how to avoid this in depth. For the session side, it's enough to configure HTTP only parameter to true. This parameter this parameter not guarantees, but it hints a browser that it shouldn't allow JavaScript to access the cookie value. So the cookie which has HTTP only flag configured will not be accessible from JavaScript. So our code document.cookie will return, for example, an empty string. It's important to know that it's not part of HTTP standard. For the first time, this flag, the funny thing is that for the first time, this flag has been introduced in Internet Explorer, a browser which is very well known as one of the least secure browsers. So the Microsoft developers wanted to make this browser more secure, so that's why they introduced this HTTP-only flag. And further, later on, this flag has been adopted by other browsers as well. Most standard browsers will use this flag and make use of it properly, but be aware that still there are browsers which do not support this flag.
Yeah, well, finally something to be grateful for Internet Explorer then.
Yeah, that's true. Okay, and a quick note that to protect ourselves against XSS in a more general way, we need to validate input and to escape outputs. In case of JSP, remember that this popular way of displaying values like $ and curly black brackets is not safe. This method does not escape the string, so it's printed out as it is, and that's why XSS is possible, and that string has been included in our page source. If you take a look at the code, I will show you a JSP page and XSS XHTML page, facelet, the code which displays opinions. Okay, this is a very simple code. We have opinion spins and we just iterate over each. And we use this $ and curly brackets annotation. And this is not safe. A very similar piece of code in Facelet, it works fine. So again, this is what I was talking about when I was warning you about frameworks. You must check out the details yourself, and you must know how the technology you are using works underneath, under the hood. Because otherwise, it's very simple and very easy to make a simple mistake.
Mm-hmm.
Okay. Another kind of session attack is session fixation. I briefly mentioned that before. The scenario here is very simple. The hacker opens a web page of a system in a browser. And usually that's the moment when a new session is initialized. The first moment we connect to a dynamic page in our application. Remember that hacker in this moment has full access to the computer he uses. So he can access our browser data and he can log down the session ID. Then he can leave the browser open. he can close the tab, but he can leave the browser open. When a user comes in and logs into the application, it uses the session initialized by the hacker. So the hacker can use the written down session ID and to hijack the user's session. So it's very important to be sure that you are using a clean browser without any session initialized before, without any user who used the same browser before. So usually it doesn't happen on our private laptops, computers, etc. But it can happen in a computer lab at your university. It can happen in any public place you are using a computer, which is publicly available to other users as well. The solution here in case of session fixation is pretty simple, and it's the responsibility of application developer to implement it properly. First of all, application developers should change the session ID after successful login. More generally, the developers should change the session ID after any escalation of privileges. In case of Java EE, we can use Java EE 7 and Servlet 3.1 specification and the method change session ID. In previous version of Java, we had to use invalidate and get session true, this pair of two methods to implement the same behavior. Okay, so we can talk briefly about secure session management best practices. First of all, we need to use random unpredictable session ID at least 16 characters long. I think that most modern Java application servers implement session ID properly and it's secure enough. In some of application server, you can configure the length of session ID yourself. We need to think about secure transparent storage of session IDs. Obviously, cookies are preferred over URL writing. We need to remember about two cookie flags, secure and HTTP only. We need to remember about consistent usage of HTTPS, because still it happens that some parts of our applications are available over HTTP and some are available over HTTPS. We need to think about static content, how to serve it to make it secure and performance-wise. We shouldn't mix HTTP and HTTPS under the same domain cookie path. It still happens very, very often that we make our applications available over HTTP as well as HTTPS. So, for example, our public part is available over HTTP and our private part is available over HTTPS. But because it's the same application, it's not secure because we can, or not we, the hacker can use this feature or trait of the browsers that they send the cookie over HTTP as well. And we shouldn't use too broad cookie paths. That's also very important to minimize the surface attack. In case of session creation and distractions, yet it might be stupid to remind you of, but we need to new session ID after login. That's not that common. We need logout button. Okay, that's funny, but still there are applications which only depend on closing which is not enough to close the session on the server side.
Yeah, so we actually have a question related to that here on the RC. So Gautam is asking if when the user logs in, doesn't the server create a new session for that user right away? Why do we have to do it ourselves?
Basically, it depends. It depends when you access dynamic page. It depends on the framework you are using.
Okay.
So basically, the session is created the first time get session is called. So it depends whether when you call it or not. And usually for Java application, it's the first time you access dynamic action. Or by dynamic action, I mean you execute any servlet method. Think about JSPs which are compiled to servlets as well. Dynamic content. So in most Java applications, that's the case, but it can be implemented in other way as well. So remember that before logging in, you can have already a session ID initialized. So your action which implements logging in to an application should change the session ID to new one. Is that clear?
Yeah, I think so. Well, I mean, one of the other things that I understood is that a user might be accessing like static content before actually doing something, and you want to change their session ID right before he actually performs any authorized action or anything that actually requires security to perform.
You should change it after login, because it doesn't matter whether or not the session ID has been initialized before. After logging in, it should be a new session ID, because otherwise it can be used in a nasty way, as you've seen. Okay, so the recommendation for session timeouts is 2 to 5 minutes for critical application and 15 to 30 minutes for typical apps, and it's well aligned with our default, which is 30 minutes for Java application. Another thing which we have not discussed so far is that we need some way to discover whether a hacker is trying to access and hijack the application. The common way to implement such detection mechanism is to implement sort of fingerprinting of the first requests. So in a user session, after logging in, we store a fingerprint for the first requests. By fingerprint, I mean like several headers, like IP, user agent. And we store this in a user session, and in any other upcoming requests in this session, we check whether the new requests matches the fingerprint of the first request. If they don't match, something's going on and it's better to invalidate the session. And this, unfortunately, is not supported in Java EE, and it requires implementation on your own. However, some frameworks out there implement and support fingerprinting.
Well, I guess we need to push that to Java EE then as well.
Yeah, that would be very useful. And from the secure point of view, a big step forward. Okay, in case of secure authentication, declarative authentication implemented using annotation or descriptors does not force new session ID after login. It's observer specific, so my choice would be programmatic authentication with Java EE7, authenticate, login, and logout methods. This way we can implement advanced flows and requirements. For authorization, I would stick with declarative authorizations and annotations. So that's been the practices for secure session management. I think that our session will be pretty well secured at the moment. And what if we can't steal a cookie? How can we attack the application? We can still use the cookie. And this is our last demo. We will make use of cross-site request forgery to use a cookie without the user's knowledge. I will log into the application. I will send you the link to the applications, and I will send another link, the attack link, with one click me button. And I will ask you to click this. And after you click the button, I will check my accounts, and luckily I will see some increase in the amount. Okay, so let's get back to Firefox. I need to turn off the proxy because I won't use it in this demo. Okay, so no, I'm changing the configuration to no proxy. And the last demo of this session. Okay, so you see my account. The balance is 1,000, let's say, Bitcoins. That's pretty huge amount of money.
That's awesome.
And yeah, that would be nice. And no transactions on my account.
Did you post it to Twitter?
Yes, I'm posting it. Wait a moment. A hijack demo 4, and please log in to your account. Any username will work fine. Okay, and the second page used here, it's the attack page, completely unsuspicious page with one click me button, and I will ask you to log in.
Yes, on it. Give me a sec.
Wait a moment, I haven't posted it yet. Okay, that's demo 4 and the attack part. Okay, so it's on Twitter, and I'm observing my amount. So far, it's not changed, but I'm patiently waiting.
Yeah, let me just copy up links over here.
Okay, so just click the button on very unsuspicious page with a very meaningful name like click me. Okay, I've got 4 transactions on my account, incoming transfers. Thank you very much. And what happened here? Show page, let's view page source. And you see a hidden form here with pre-filled values. The to field is set to Patrycja, the amount is set to 666, and the other parameters are just the parameters generated by the framework Java Server Faces, which is used in these demos. Mm-hmm. So basically, this is another feature of a browser. The browser sends a cookie always a cookie when the request is sent to the same domain name. So even though the page comes from a different context, the form can send an action to a completely different context, and the cookie will be sent together with the request. So basically, I've used a pre-filled form, and that's why, and I've used the pre-filled form, and I tricked you to click the unsuspicious button, and in the background, the request has been sent to your account, the application server, and the transfer has been performed. Mm-hmm. So I guess that all of you have heard about cross-site request forgery, and that was the example of cross-site request forgery. And I'm sure that many of you has heard about the solution to cross-site request forgery, which involves usage of a unique token for each request. It's so-called anti-CSRF token. And I think that most frameworks, like not all frameworks, support anti-CSRF token. Usually as developers, we secure our web forms and we forget very often about our REST services. We need to secure our REST services as well. So basically the solution is web framework dependent. In case of Java Server Faces, which has been used in my demos, I had to turn off anti-CSRF token, which is by default included in every JSF form. So awesome. Yeah, that's pretty awesome. But again, it was improvement over versions, because the first tokens which were included in JSF 1.0 were not strong enough. Because anti-CSRF tokens need to support the same features as session ID, so they need to be randomized and long enough to be secure. In JSF 1.0, the tokens were not secure enough because it was just a sequence, so it was very easy to guess the next value of a token. Mm-hmm. So the conclusion after today's session is that you are never safe. You are never safe, and you will never be safe. So, so basically, we need to improve ourselves. Nobody's perfect. We all make mistakes. There is no system that guarantees complete safety to its user. All we can do is to improve ourselves as developers. It means learning, and once again, learning. So thank you. That's all for today. Hope you enjoyed the demos, and now it's time for your questions, if you have any more.
Yeah, I think everyone that was watching the live stream was enjoying your demos, and we have a lot of activity here on RC regarding the demos and questions as well. So everyone that wants to send a question, please send us on IRC. We have a couple of them that I already asked you about. So we have P. Dermin asking if there is any framework in Java that support fingerprinting checking that you can use.
Spring is pretty mature, and Spring Security has a lot of features implemented out of the box. The features I was talking about today.
Okay, so you will.
And I think that many developers in Java use Spring, so take a look at Spring and Spring Security and configure it in details.
Okay, but do you advise you can combine like Spring Security with this Java EE stuff as well?
I think it's for most application it's neat to configure it in one place, right? So it's better to have it in one place instead of splitting it into multiple configuration files. So for sure, you need to know your tools, and as developers, we need to read the documentation. Yeah. Yes, that's boring, but that's what makes us better developers.
Of course. And we have some, so Gautam is asking if the source code for your demos are available anywhere.
It's not available yet, but some sort of improved version of this talk I will give at Java 1. So after Java 1, I'm gonna publish code examples to GitHub. So
great. So
keep an eye on my Twitter.
Yeah, so we can expect them in like roughly 1 month or something.
Yeah.
Yeah. I think we're done with questions. At least we don't have anything else on RC. What's left for me is to thank you so much for your time. I think that one of the biggest concerns on the industry at the moment is everything related with security. It's a real issue, and developers need to be aware what's happening out there so they can prepare and develop their applications accordingly.
Absolutely.
So thank you so much for your time. I think people enjoy that. For me, I'll just say goodbye to our users. Let me check. So just one small detail. I think we have a next session in September, I believe. Yeah. And next session is going to be with Aaron Gumta, a regular here on the VJug, and he's going to talk about Docker for Java developers. He already gave a session before, but now he's going to do a refresh for that session. So please stay tuned and join us on VJug for the next time. Thank you so much for watching, guys, and bye-bye.
Thank you. Bye-bye.